explain the cardiac cycle. Okay, we will explain the cardiac cycle. Okay, cardiac cycle so much easy. Okay, so you will understand everything so much easy. So here is the cardiac cycle. So cardiac cycle, the first thing is the you have to understand the cardiac cycle is that what, for example, this is your heart. Okay, heart have four chamber. One is the two. Well, these are the atria, okay, and these are the ventricle, okay. So, for example, this is the left atria and left ventricle. This is the right atria and right ventricle. Blood come here, and blood, for example, blood come to both of them, okay, and from both of them they move, okay. From the right, all blood from the body come to here, okay, and from the atria go to the ventricle, and from the ventricle it go to the pulmonary trunk, okay, pulmonary trunk through the pulmonary trunk. This is the, I will draw. From here it go toward the pulmonary trunk. From here it move toward the pulmonary trunk, okay. And from the lift end, and from the lungs, from the lungs it comes, from the lungs it come to the left atrium and left ventricle, and from the left ventricle it goes through the aorta. It goes through the aorta to all body, okay. So this is simple mechanism. We will explain that how this is your heart, how this contract and not how this contract and the legs. So we will explain it in the cardiac cycle. So the first thing is the atria. So both of them will occur at simultaneously. Okay. So we will explain only one atria and one ventricle. For example, there are four chambers. If the atria contract here, atria also contract here. If the ventricle contract here, ventricle also contract here. If it complete in 0.8 second, they also complete in 0.8 second. So we will explain only one of them. So now just go to the cardiac cycle. One is the atria. First is the atrial contraction. Okay, after that atrial contraction, when the atria contract, okay, what will happen? Another isovolumetric contraction here take place, then rapid ejection, and then ventricular systole occur, and rapid ejection. Okay, so the first thing is you have to remember that in the cardiac cycle, one is the atria contraction, another is the ventricular contraction. Mean dice atria when now first of all when the atria contract, okay, for example, now this is your heart, okay. First of all, diastole, the blood goes to the heart, okay, from to the atria to the ventricle, both of them, okay. When the ventricle fulfill, okay, and now more blood can't come it passively. So after that, the atria, this is the atria contract and contract all the blood to the ventricle by forcefully, okay. When the atria contract, after that, what will happen? So the atria contract, okay. Now when the atria contract, this is your atria contract, it force all the blood to the ventricle, okay. After that, what will happen? Isovolumetric contraction start, okay. Isovolumetric contraction, this the after that, this is the mitral or tricuspid valve, they closes, okay. The atrioventricular valve closes, and this is the ventricle move blood to the from this move blood to the aorta and pulmonary trunk. So after atria contraction, if the atria contraction occur, what will happen after that? These contract, the ventricle contract so forcefully, but no blood move out or no blood move in, okay. At that time, no blood come in, only contraction occur, and the pressure is increases. Actually, the pressure is increases, the pressure is so much increased that it become increased from the aorta and the pulmonary trunk. So the isovolumetric contraction occur in the ventricle, okay. After that when the ventricle contract and the pulmonary are, this is the ventricle. When ventricle contract isometrically, no blood move out and no blood move in, so the pressure is so much increases, and there is the aorta, okay. And from the aorta pressure is like this, and the ventricle pressure is so much increased. If the pressure is increased in the ventricle, the aorta the aortic wall open. When the aortic wall or pulmonary wall open, the blood move to the aorta and or pulmonary trunk. Okay, if the so the blood move to the aorta. This is simple mechanism. In isovolumetric contraction, pressure is so much increased that it increase from the aorta or pulmonary trunk, and blood move to the lower pressure, okay, through the aorta. Now this at this mechanism, when the blood move out, this is called rapid ejection. Rapid ejection phase. The blood move out so rapidly, okay. Now this is called rapid ejection. After that, when the blood is moving out from the ventricle, the pressure is decreasing. The pressure is decreasing, okay, but not too much. The pressure is decreasing and the blood is moving out. So when the rapid ejection occur, after rapid ejection, the pressure is the pressure of the ventricle is increased. So the slow, after that, the ejection is going on, but the ejection is the slow ejection, okay. The slow ejection, reduced ejection occur. And you have to remember that actually these all phases, the first is the isovolumetric contraction of the ventricle. After that, the rapid ejection and slow ejection. In these all three phases, isovolumetric contraction, and after that rapid ejection, and after that reduce ejection. These three phases is actually contraction of the ventricle, contraction of the ventricle, and it is called systole. Okay, systolic phase. This is called systolic phase. Now when the if the after slow ejection, when the slow ejection is completed, no more blood is moving to the aorta or pulmonary trunk. So the aortic and pulmonary valve closes, and because the pressure is less here and the pressure become increase here. So when the pressure is increasing here, so this valve closes, that no more blood coming back to the ventricle, okay. So this is called systole. This phase is called, these three are called systole, okay. After that, when the aorta wall is closes, and now we will explain what will happen. After that, isovolumetric relaxation occur. For example, isovolumetric relaxation. This is your atria and this is your ventricle. These ventricle contract so much, okay, after the reduced ejection. But when the aortic wall closes, they start relaxing. Isovolumetric. No blood is coming here, but the ventricle is relaxed. When it is relaxed, its volume is increases. When volume is increases, pressure is so much less than the body. So from the blood from the body, all the body come here. So in first phase, there is isovolumetric relaxation. No blood is coming here because the aortic wall and the mitral wall are closes, okay, actually. So isovolumetric relaxation happen, and the pressure is so much decreases. So the atrioventricular wall is open. After that, the rapid ventricular filling occur, okay. What? Rapid ventricular. When this wall is open, so more blood come in, more and more blood come to the ventricle passively, okay. No need of force anything, just passively. So first is the isovolumetric relaxation will happen, okay, because both of the wall are closes, no blood coming in and no blood going out. So it is iso, same volume, okay, but relaxation. At second phase, the mitral wall or tricuspid wall is open, so it is called rapid filling, that more blood coming in and the ventricle is filled. At the third, what will happen at the third? Reduced ventricular filling. At the third, the filling, the blood is coming in, but it is slow. That why it is called reduced filling, reduced ventricular filling, okay. So these three phases are occur. After that, when the reduced filling occur, no blood come in, okay, just normal. Both of the pressure in the body and pressure in the ventricle is same, no blood coming in, because there is no pressure difference. So after that, this is the atria and this is the ventricle, so both of pressure is same. So actually this wall is open, okay. So now the atria start contracting. When it contract, it force the blood to the ventricle, and that is called atrial contraction. Okay. So the atrial contraction happen, and this is actually the diastolic pause. Okay, this is actually diastolic phase. You have to remember this, that isovolumetric relaxation, rapid ventricular filling and reduced filling is actually ventricular diastole. This is ventricular diastole. This is ventricular. These three phases are ventricular diastole. Okay. Now you have these all are the phases. Now come here to the atria. When the atria contract, what will happen? Rapid atrial pressure. The atrial pressure is increases. This is the atrial pressure A wave. This is the atrial pressure is increases. Okay, and now this is in ECG. If you see here, the P wave will be measured. The P wave will come. Okay, in isovolumetric contraction, what will happen? This is ventricular depolarization. Ventricular depolarization is a happen, and isovolumetric contraction is occur at the QRS. When QRS complex is formed, at that time isovolumetric contraction is occurring. Okay. Now the left atrial pressure is also decreases here, but after that this is increases because the blood is flowing to the atria. Okay. Now you have to just reduce ventricular, just there is no now at the rapid ventricular ejection. What will happen at the rapid ventricular ejection? This is the pressure. Okay, pressure is so much increased. Now the pressure is decreasing, and the ventricular is the ventricular the when the blood from the ventricle move to the aorta. Okay, and here is called ST segment. At ST segment, the ventricular ejection is occur. Period between the ventricular depolarization and repolarization is called ST phase. But in the ST phase, rapid ventricular ejection is occurring. Okay, now at 4, reduced ventricular ejection. How? What is the at 4 the reduced ejection fraction is occur? You have to remember that blood flow not by the ventricular contraction. Instead, it is due to inertia of the blood. For example, when the atria, I have discussed the first of all the ventricle contract isometrically, then rapid ejection occur. After rapid ejection, reduced ventricular filling occur. Reduced ventricular filling is not due to pressure of the ventricle. It is actually inertia. Inertia that, for example, if you start, if a car moving, this is a not a plane road, in an inclined plane. In a car, there is a car. Okay, and a car is moving here, the car is moving here, and here the car speed is so much high. Not from this area there is no need of engine to start or etc, but the car is move on yourself, and if it go to here, the inclined plane is finished, but the car is also moving here without engine. Okay, without starting. So what is the mechanism? Because here, from here, it move due to inertia. Okay, just like this, the blood is going here due to contraction, and after that there is no contraction, there is actually the inertia. Now ventricular diastole is actually isovolumetric relaxation. At isovolumetric relaxation, what will happen? This is the aortic pressure. The aortic pressure is actually decreases. Okay, and after that it is increases, because first, when the blood is not moving to inside, not moving to the inside, the when the aortic wall contract, so the pressure is increases. Another is also, here is the dicrotic notch, the dicrotic notch. Okay, here is also this notch, and this is due to the blood move isovolumetric relaxation. Blood is coming to the atria. Okay, here. Okay, now the diaortic notch, the actually the pressure is actually decreasing here. Okay, in the ventricle. So left ventricle. Now see here, this is the aortic pressure and aortic atrial pressure. Here is also the atrial pressure. In atrial pressure, first it is decreased, but isovolumetrically means that blood is not moving to the ventricle. It is accumulated in the atria. So the atrial pressure is increases here, and the left ventricular pressure is decreases so much. When the left atrial pressure is so much increased, after that, when the wall is open, the rapid ventricular filling occur. Okay, now after that, the reduced ventricular filling is also occur. That is called diastasis. Now you have to remember that there are phase 7 to phase 7 plus 6. These are 90% passive ventricular filling. Mean that there are the passive ventricular filling are occur in the rapid ventricular filling and reduced ventricular filling. But 10% filling of the ventricle occur due to atrial contraction. You have to remember that for example, this is your ventricle. To the ventricle, 90% blood come due to one is to the due to rapid filling, rapid ventricular filling, and next is the reduced ventricular filling. This is 90%, okay, and 10% is due to atrial contraction. Atrial contraction, okay, 10% is due to atrial contraction. Now this is so simple things. Now we will explain the cardiac work, okay. So if this is don't waste your any time in this etc, this is so much, don't confuse yourself, okay. Up to this you have to just remember the pages. This is so much, just like this you have to remember only these pages. This is very important for you, only these pages, not so much detail about this, okay.